So in this question here, we've got a curve which has the equation y equals x cubed minus 5x squared. And on that curve, there is 2 points with the rate of change of y with respect to x is 4. We need to find x to 3 significant figures, but before we can do that, we need to find an equation for the rate of change. Now, when we're looking at rate of change, and it says with respect of y to x, what we're looking for is derivatives. That's what this is all about. So the rate of change is always the derivative. So the rate of change of y with respect to x, we just write this as dy dx. The change of rate of y with respect to x. And what we want to do is find out when this equals to 4. So 4 is going to equal this at some place along the curve. But first of all, we need to find the equation for the rate of change. So what we need first of all is to find the derivative of this equation here. So let's just take that off. So dy dx, what we're looking for y, we just write in this formula instead of our y. So we want the derivative of x cubed minus 5x squared. So that's our y. So dy dx, as that stands for y. Now this here is a good old-fashioned power rule question. So the power rule is where we look at the indice of each of the terms inside this derivative question. So x cubed, let's have a look at that first. So if we take the indice, it's a 3. So we bring that to the front and multiply it by the coefficient that's already there. Well, here the coefficient here is actually going to be a 1, isn't it? Because there's nothing there. So therefore 3 times 1 is 3. We keep the x because that's what we're taking the derivative of. And then we drop this power by 1. So that's our first part of our answer. Now, when we've got a minus sign in here, or a plus sign, this is we also use the sum rule. So what we can do is we continue along with this operator. So if that was a positive, we continue with a positive. If this was a divide or a multiply, then we can't do this method. Okay, so let's go with this one, using the same rule that we did for this. So the indice is 2. 2 times our coefficient, so that's 5. 2 times 5 is 10. So that becomes our new coefficient of our derivative. And then we drop the power by 1. So the x to the power of 1 just stays as x. So that's the first part of our answer, 3x squared minus 10x. What we need to find out now is when this derivative is equal to 4. So we need to now set this to 4 for the next part of our question. So we've got 3x squared minus 10x equals 4. Okay, well we've almost got a quadratic here. If I bring this 4 to this side and set it to equal to 0, we've got something we can solve. So we've got 3x squared minus 10x minus 4 equals 0. Okay, now looking at this, I'm not sure I know how to factor that. So I'm going to leave factoring out. So I'm going to go straight into the quadratic formula. So quadratic formula, I've got my minus b plus or minus square root of b squared minus 4ac all over 2a, and that gives me my x. So that's what we're going to use. So that's our formula. Let's just keep that in the box nicely. Okay, so let's work out what we can use for our inputs here, our b, our a and our c. Well, our a is our x squared coefficient, so a equals 3. Our b is the coefficient for x, so b is minus 10, and c is our constant, so c equals minus 4. Okay, right, let's plug that into our quadratic formula. So x equals minus b, so minus 10, so that becomes plus 10, and then we've got plus or minus, so that's where we get our 2 solutions from. So we're going to need 2 solutions to this question. B squared minus 10 squared, that's 100. So we've got 100, and then minus 4, let's work this out. 4AC. They got 4 times 3 times minus 4. So 4 fours are 16. 16 times 3 is 48, and not forgetting this minus sign. So we've got minus 48 over 2 times A. So that's going to give me a 6. Okay, right. Well, let's just simplify this up a little bit, and then we can hopefully get to our answer. So plus 10, I'm just going to write this 10, plus or minus square root 100 minus 48, that's 148, and divide that by 6. Okay, now what can we do here? Can we break up this third here? Well, 148, I know 4 will go into 148, so that will go 37 times 4. So I've got x equals 10 plus or minus 2 root 37 over 6. Okay, so now I've got my two solutions looking here. So now let's just leave these calculations here. Let's keep this calculation here. Let's write my bits in here. So x equals, now look, we can divide everything by 2 here. So if I divide this by 2, I'll get 5. And then I'll put my plus solution in here. 2 divided by 2, that cancels. Square root of 37, so 5 plus root 37, and then that's divided by 6 divided by 2 is 3. Okay, and now I've got my minus solution. So x equals 5 minus square root of 37 over 3. Okay, now what have I got here? Well, square root of 37 is almost 6. It's just larger than 6. So I've got 5 plus approximately 6 divided by 3. So that's about 11 divided by 3. So if I plug that into my calculator, I will get to 3 significant figures. That's what I need. 3.69. That's what that rounds up to for 3 significant figures. Now here I've got approximately 6, just over. So 5 minus 6 is minus 1. Minus 1 divided by 3 is approximately minus 1/3. So put that into my calculator, I will get approximately 0.361 for 3 significant figures. So that's going to give me my solutions. So x is approximately 3.69, or x is approximately minus 0.361. Should have put my minus sign in there. Okay, so that would be a good place to stop. Okay.